Okay, here's lesson 4. This is taking applications one step further, and these are like my favorite problems. I love mixture problems, but sometimes people get really confused with them. So you can watch this over and over again until you can get it. Or if you're really still having trouble, talk to your instructor about it, because I just don't want you to get real frustrated and say, forget it, I'll never get it, because you will. It just takes a little time and a little effort. You can do it. All right, so the strategies is exactly the same as the one we just did in the other lesson. So here's the first mixture problem. A chemist needs 10 liters of a 50% salt solution. She has available 20% salt solution and 70%. Notice how 20% is less than what she needs, 70% is more than what she needs. So I'll be able to use those two things in together, not necessarily having the same amount of each, to make a 50% solution. So she wants to know how much she's going to need. So she needs 10 liters of the mixture. So the amount of the mixture she needs is 10 liters. And I'm going to put an L here for liters so we remember. Now the percent of full salt that she needs for the mixture is 50%. So I'm going to write that as 0.50. The percent in solution number 1 is 0.20. And the percent in solution number 2 is 0.70. Okay. How much of each does she need? So we don't know how much of the 20% solution we need. And we really don't know how much of the 70% solution we need, but we can use these two numbers right here to make sure we get a representation for this. This is what she needs in total. She needs a total of 10. Part of it is X. So the rest of it would be 10 take away X, because when you add these two things up, you'll get 10. So she needs, the whole thing is 10, but part of it is the 20%. I'm subtracting that off. The amount of pure salt will be, just multiply these together, 0.20x. Multiply these together, and make sure you put the 10 minus x in parentheses, because eventually we'll distribute. And 0.50 times 10 is just 5 when you go to multiply it. So now, the amount of pure salt in solution number 1 plus the amount of pure salt in solution number 2 has to equal 5. So yay, so here we go. So it's going to be 0.20x plus 0.70, 10 minus x is equal to 5. Yay, so I'm going to distribute. So 0.20, didn't look like point there. And then I'm going to multiply 70% of 10 is just going to be 7 minus 0.70x is equal to 5. So don't break out in a cold sweat yet, since we're going to have a negative here. It'll be negative 0.50x plus 7, because I combine like terms on a side. We can't forget how to use our equation steps. I'm going to subtract 7 from both sides. And I'm psyched because I have a negative on the left and a negative on the right. I'll get negative 0.50x is equal to negative 2. Then I'm going to divide both sides by negative 0.50. So x is going to equal, so if you think about it, I'm going to I can move my decimal point here. So I'll really get negative 20 divided by 5, which is 4. For what? 4 liters of 20. And then how many of the 70% is going to be 10 take away 4. So it'll be 6 liters of 70%. because remember this 6 comes from the representation here of 10 take away x, and we figured out that x was 4. So there you have it for the mixture problem. Let's do another problem. Yeah, let's. Okay, so this is another type of mixture problem, and this one is like my all-time favorite because it has coffee in it. So let's go for it. A manager of a coffee shop has one type of coffee that sells for $5 a pound, and the other type that sells for 15. So the cheap coffee is $5 a pound, and the expensive is 15. A manager wishes to mix 50 pounds of the $15 coffee. So I'm going to write 50 pounds here. So as I read, I fill in what things are. I try not to get overwhelmed about what things are. I just kind of go like, well, what was that representing and where should it go in my table? And they want to get a mixture that will sell for $9 a pound. How many pounds of the $5 coffee should be used? We don't know. So you're like, okay, this is good, but I need this mixture guy. Well, the mixture guy right here is I need to mix x plus 50 and I will get my mixture. Because I use some from the $5, 50 from the $15 to get x plus 50. Now the total amount of money invested in the cheap would be 5x because it's $5 a pound times x pounds. The total amount of money invested in the expensive would be 15 times 50, which would be 750. And then the total amount of money in the mixture, I just am really careful. I'm going to do 9 times x plus 50 and make sure that my expression is getting ready for the distribution. So here is my lucky equation. The amount of money invested in the $5, the cheap coffee, plus the amount of money invested in the expensive coffee is equal to the amount of money in the mix. Good. So now I'm going to distribute. So I'll get 5x plus 750 is equal to 9x plus 450. So I'm going to move stuff around, and I'm going to move the 450 over because I really hate dealing with negative numbers. So this will be 300. And then I'm also going to move the 5x over to the other side. So I'll get... So here we go. So 300 is equal to 4x. I'm going to divide by 4. So x is equal to 75 pounds. So we need 75 pounds of the $5 coffee. I guess I could have just said the cheap one. And that is the whole ball of wax for the mixture piece of this. Good luck doing your problems in the book and then doing your My Math Lab assignment.